Hi everyone, this is Team 18's Senior Project in Computer Science for CS 426, developed in 2021 to 2022 in the Department of Computer Science and Engineering in the University of Nevada, Reno. The team members are Tyler Becker, Brady Blendo, Nathaniel Daniel, Philip Hensley, and myself, Alexander Tello. Our instructors are Dave Filecipher and Devrin Lee, and our external advisor is Monica Nicolescu. Together, we create an application to develop high article task trees, or HTTs. These HTTs allow users to control robots with a visual interface by adding, removing, and editing nodes. We wanted to increase the usage of HTTs in robotic research, which essentially eliminates human error, makes HTTs more accessible, and can visually show the information of the tree to debug. Thank you.
So as was stated before, HTT-Viz is a visual editor for hierarchical task trees, or HTTs for short. HTT-Viz allows us to edit, load, save, and even debug hierarchical task trees that are running on the computer. In front, on the screen, is a representation of a hierarchical task tree meant to describe the task of eating dinner. The topmost node is just the whole task, eating dinner. Below that is a then node, which enforces that its children be run from the left to the right. So the first node that will run is this or node, and it will either grab water or grab soda. Then it will make food, and finally it will eat the food and drink the drink. So and nodes run both of their children. This is a data structure made for robotics in order to describe these complex tasks to robots as a set of simple behaviors that need to either be performed in some order, performed together, or performed one or the other. So the reason we created HTT-Viz was to prevent users for HTTs from writing these long description files on the left. What was frustrating before was any mistakes in these description files would cause unforeseeable bugs that would appear when running these trees on the architecture itself. The right and left images here are actually the same HTT, one made with HTT-Viz, and then saved to produce the file on the left. However, being able to just visually create this tree obviously makes it much faster. So this tree itself is a tree with 5 nodes, each of which draws a single character using the arm of the PR2, which is shown on the right. Draws a T, a Y, an L, an E, and an R. This is a showcase of how powerful being able to create these trees quickly can be. With just a simple behavior like this, it can take less than a minute to create a tree that draws this name, entire sentences, and it wouldn't even take longer than some amount of time to write out entire paragraphs with just this behavior. Not to mention the temporal constraints this allows us to control. This is what HTT-Viz was for. Thank you.
Hello, my name is Nathaniel Daniel. I will be going over my contributions to HTT-Viz, specifically the main view as seen here, the node view, and the import and export menus. One of the most important aspects of our project is the physical node view, or the visual representation of the tree. I've developed a widget for Qt, which allows the user to visualize a hierarchical task tree. Here is an example of that widget. A single node in a hierarchical task tree in this widget is composed of 3 elements: the border, the interior, and the interior text. As the interior text of a node gets larger, the border and interior of the node will get larger to accommodate for it, so the text will never run off the sides. A node is also capable of being moved around to the user's liking. When a user wants to start designing a tree, they simply add a node to the root node, first by selecting an option from the menu on the left. I'm going to select an AND node. Right-clicking the node and hitting Add Child Node. This will add that type of node to the tree. A user can also add additional nodes to this new child node. The tree will try keeping things as clean as possible. You might have noticed that there is a line between parent and child. This line helps show the relationship between nodes, so that even if you mess up the order, it's fairly clear the relationship between the nodes. The line's position also automatically updates when you move nodes. This is done by getting position updates from PyQt whenever a node changes its location, parent or child. As you can see here, if the parent moves, the line's location is updated. Similarly, if the child moves, the line location is also updated. This gives the user a clean representation of the relationship between nodes. If the user makes a mistake and wants to delete a node, all they have to do is simply right-click a node and hit Remove Node. This will remove the node from the tree. The user is also capable of cleaning up some bigger mistakes. For example, constructing a small subtree, and then hitting Remove Node. When a node is deleted, all its children are deleted as well. This allows the user to quickly and efficiently clean up mistakes. For example, if they design a subtree without meaning to, or realize a subtree is no longer necessary for the proper functioning of a hierarchical task tree. If the tree gets large enough that it goes off the sides of the window, a scroll bar appears the user can pan. As a result, they can always access all nodes of a tree. When a user is finally done designing, they can hit the File button and hit Save, or Save As since this is a new tree. This opens a save window where you can type in the file name. I'm going to name this one File. This generates a new file, which can be opened to inspect its contents. As you can see, this is a representation of our tree. The node list, root, and draw are reflected here. There are also node definitions for the nodes that we use: draw, grab, and move. These node definitions are required for the proper functioning of our tree. This data also persists the location of nodes. So when this tree is loaded again, you'll get a tree that looks exactly like this, with no differentiations in location. The title of each node is also persisted, so that users may change the title of nodes and have it persist to files and the file, and be able to reload this file and have the file name change be reflected in the editor. If a node file include cannot be loaded, the program will repeatedly prompt the user to find these files. However, this is covered later more in depth. This is the basics of using HTT-Viz and my contributions to this application. Thank you.
Hello, everyone. My name is Philip Hensley, and I will be covering all of my contributions to HTT-Viz. Primarily, I created a lot of quality of life features for our program, including an organized tree button, an export PNG button, and a settings menu. To start off, I'll talk about the organized tree button. As the user adds more and more nodes to their tree, eventually it will reach a point where nodes overlap. In this event, or in the event where nodes are accidentally misplaced and the tree becomes unreadably cluttered, the user can just go up here and press this button. And the tree will be automatically organized to remove any clutter and to remove any instances where nodes were overlapping. On top of that, there is an Export PNG button. This button allows the user to, as it says, export a PNG of their tree. This allows the user an easy method to view their tree in the future without having to run the whole program, and also to share a simplified version of their tree with others. Next up, I'll be covering the settings menu. There are a few options in here, and I'll start off with auto organize. When this is on, if it ever happens that nodes are added that overlap, it will actually automatically organize versus the user having to click the button themselves. As well as that, we also have the ability to change the colors of nodes. If the user per se wanted it to look like this, and they wanted the border color to look like this, they could absolutely do so. And in the end, they could also change the background window color to, I don't know, let's do this one. And with all these features comes the config file where the choices are saved. What that means is if I go ahead and close this program and reopen it, you can see that all the colors have stayed the same and auto organize is still active. Thank you so much for listening in. And this has been Phil Pensley and my contributions to HTT-Viz.
Hello, I'm Brady Blundell. One of the aspects of HTT-Viz that I contributed was the inclusion of the edit window. This window can be either accessed by right-click Edit Node or by simply double-clicking on a node. From this window, the user can change the display name of a given node to better reflect its purpose within the context of the tree. Additionally, the user can use this window to change specific parameters within the node to change the instructions delivered by the behavior. This allows the user to forego finding and manually changing these behaviors within a YAML file. Additionally, I implemented the unsaved content check. If a user tries to close without saving, they're given a warning and given the option to either save or close. If they save, the changes are reflected, and if they choose to close anyways, no changes are made. This is also true if the user tries to open a new file, tries to open an existing file, or simply tries to close the main window. If there's any unsafe content, the user will be notified. Otherwise, they can simply save. Next, I helped in implementing the undo and redo functionality. This allows the user to undo changes they have made or redo them in the case that they were not a mistake. And this is also true for whether or not they want to add or undo a node. Finally, I assisted in the inclusion of the file dialog that allows the user to save and load these visual trees. In the case of opening files, there were a few unhappy paths we had to take care of. The first was a file not found error. This was caused if the file paths for the node file includes were not correct for the given system you are on. In this case, when the user attempts to open one of these files, they are asked to find the missing behaviors. When they find the behaviors and include all the necessary files, the tree opens as normal. The second problem was importing older files. In this case, this file does not have the necessary variables, the X and Y coordinates for the node, or the title for the display name. In this case, when attempting to load this file, it simply loads as normal. This is because the nodes are given a default X and Y coordinate of 0, and then the tree is automatically organized, and the node name or node display name is defaulted to the default name. Thank you.
Hi, my name is Alex Tello, and this is my contribution for HTT-Viz. With certain functions being implemented in HTT-Viz, test files had to be created to ensure these functionalities were working properly. Using PyTest libraries, we were able to create multiple tests, including a test that would load, edit the tree, save the edit, and load the same file to test if the loaded file was properly saved. This was called a round-trip test. Another test that was created is the organized button Qt test. That checked if the feature was behaving properly when pressed. A plugin and a wait signal test were created to ensure all tests did not interfere with each other during runtime, and to ensure all plugins were operating without any issue. A configuration test was created to test HTT-Viz config file once it was created. I'm going to navigate to my command prompt to demonstrate. So I'm in my HTT-Viz test file and make sure the testing file is in there. And I simply run the function PyTest. And we can see the results. So overall, everything in the team program seemed to be working properly, as all the tests that were created were passed. Thank you. My name is Alex Tello, and this was my main contribution for HTT-Viz.
This project is HTT-Viz. Thanks for watching the video.